Welcome everyone. So today we will solve Leetcode problem 54, spiral matrix, and we will be solving it using Golang. So this problem states that we are given an M cross N matrix, and we want to return a single array that will contain the matrix elements in the spiral fashion. So if this is a matrix in example, then our response will be, then our resultant array will be 1, 2, 3, then down 6, 9, then left 8, 7, then top 4, 5 until and unless all the matrix elements are covered. So we will solve this problem by brute force, exactly the way it is mentioned in the example. We will traverse the array elements first from left to right, then we will traverse elements from top to bottom, then bottom to left, and then left to top again. So we'll maintain 4 pointers. One is row beginning and row end, column beginning and column end. So row beginning will be 0, row end will be n minus 1, column beginning will be 0. So sorry, row beginning will be m minus 1 since it is m cross n, and column beginning will be 0, column end will be n minus 1. We will keep on increasing the row beginning pointer and we will keep on decreasing the row end pointer. Similarly, we will keep on increasing the column beginning pointer and decreasing the column end pointer until and unless we have reached the middle element in the matrix. And once column beginning equals column end and row beginning equals row end, then that is the point where we have reached the last element and where we have like gotten a resultant array fulfilled. So now let's code this up. First, we will check if our matrix is nil or our length of matrix is 0. If it is, we just return an empty slice. Now we create a resultant slice and this will be integer and it will initialize all the elements with 0. Now we'll declare row beginning pointer as 0. Similarly, we will declare row end pointer as length of matrix minus 1. So column beginning pointer will be 0, column end pointer will be length of matrix 0th element minus 1. Right, so this is the column beginning and column end. Now we will traverse till row beginning is less than equal to row end, and column beginning is less than equal to column end. Right, so we will traverse first from left to right. So our j will be equal to column beginning and j will traverse till it is less than equal to column end and j plus plus, and we will append the element to res. This will be matrix row beginning and j. So now we have reached here. So when we have reached here, we will decrease our row beginning. We will increase our row beginning because we have covered this row, right? So we'll increase our row beginning. Similarly, we will traverse from, I'll copy this, and now we will traverse from top to bottom. Now since you are traversing from top to bottom, I will do j is equal to column, it will be j equal to row beginning, and j less than equal to row end, and j plus plus, and we'll append this with row matrix j column end. So now we have traversed this column as well. Now we are traversing this column and we'll go from j row beginning less than equal to j row end. And now since we have traversed this column, we will decrease column end. Now we will traverse from right to left, and we will only traverse from left to right if our row beginning is less than equal to row end, because if it is not the case, then there is no way we can traverse from right to left, right? So I'll just copy this up again. I'll paste this up. Now we need to traverse from right to left. So we are at column end, and j will be equal to column beginning, and j minus minus this time, and we will append row end j, right? And at the end, since we traverse the last row, we will decrement row end here. Now I will copy the same thing again, paste it. Now we will traverse from bottom to top, right? And we will only traverse from bottom to top if our column beginning is less than equal to column end. Now we will do j will be equal to row end first, and j will be greater than equal to column beginning, row beginning, and j minus minus, and we will append this row with column beginning. And at the end, since we have traversed this column, we will increment column beginning. We'll increment column beginning there. Yeah. So at the end, we will just return res and see if it works. And we are getting wrong answer. Let's see what's the wrong answer. Uh, so we are here. This is not getting fifth element. Okay. Uh, row beginning, column end. Okay. We traverse from j equal to column beginning, j less than equal to column end. We append res matrix row beginning j. Okay, this is correct. J equal to row beginning, j less than equal to row end. Okay, j plus plus. We append res matrix j column end. This is also fine. Now, when a row beginning is less than equal to row end, we traverse from right to left. J equal to col end, j less than equal to greater than equal to col beginning. There's append row end j. Okay, row end minus minus then. And then from bottom to top, since we are traversing from bottom to top, oh, I think since we are doing this, I think I need to do this here call. Yeah. Now let's run this up. And we can see it works. I'll submit it now. And we can see it passes and it's pretty efficient. So this was all for today. I'll see you in next one.